Okay, welcome to Chapter 7. Chapter 7 is all about similar polygons. And before we can really talk about similar polygons, we have to do some review of some prior concepts of math that you have learned. Ratios and proportions. And here we are with sections 7, 1, and 2, where we'll do just that. You'll have to excuse me, I've been working out, a little bit sweaty, but we'll get through that. So, what is a ratio? A ratio is a comparison of two quantities. There are three ways to express these. We can use the word to, T-O, A, to B. We can say A to B using a colon, or we can say A to B in the form of a fraction. These three ratios are comparing the same two things, A and B, and for each of them we'll say A to B. Ratios are usually expressed in simplest form. Oh, I forgot. B can never be 0. What would happen if B was 0? Well, we'd have 0 on the denominator, which would make part of something explode somewhere. It's never good. 0 can never be on the bottom. Ratios need to be in their simplest form, or at least they usually are. So 5 to 15 is the same as, well, 5 goes into both 5 and 15, so it can be reduced to 1 to 3. 6 to 15, well, 3 goes into both of these, so it can be reduced to the expression 2 to 5. 9 to 12, that looks like a fraction, because it is, and 3 goes into both 9 and 12, so it can be reduced to 3/4, and really no different than what you've been doing for a long, long time. Ratios can be used to compare more than just two things. In this expression here, m to n to k, we can take any two parts of that and say m to n to k, m to k, all of those things will go together, those three expressions, or if we had 4 or 5, they all could be related to each other in the form of a ratio. And then they can be reduced similarly as well, as you see in this example. 16 to 10 to 4 can be reduced by a factor of 2 to get 8 to 5 to 2. I expect these are things, all concepts you've seen before. So here's an example of some things you'll be doing out of this section. Express each ratio in the simplest form. This is asking us to express out of this triangle over here the length of AB to the length of AC. Well, AB has a length of 12, BC has a length of 27, so 12 to 27 is the ratio. Oh, but wait, 3 goes into both 12 and 27, so we can reduce this to a smaller ratio. 4 to 9 is the answer. I expect that you could probably do this, so give these 7 things a shot. I think you can do it. The answers will show up here shortly. Do it on your own first. I should probably see some work as well. Okay. How'd you do? Did you get them right? Do you understand what you did wrong? I hope so. If not, ask me questions. Okay, example 3 here gives us a good way that ratios can be used. So two complementary angles have measures in the ratio of 2 to 7. Find the measure of each angle. So here's what we're going to do. When you see a ratio like this and you're trying to find, you're going to throw in a variable and create this expression of 2x and 7x from the ratio 2 to 7. So if our two angles represented by 2x and 7x, they're complementary, we can write this equation. 2x plus 7x equals 90 degrees. So 9x equals 990, so x equals 10. But that's not what the question is. The question says to find the measure of each angle, so you just got to plug the 10 back in. So the two angles are 20 and 70. Well, that one was pretty simple. Let's look at one that's less simple. The measures of the 5 angles of a pentagon are in the ratio of 11, 7, 5, 4 to 3. Find the measure of each angle. Well, first of all, the sum of the 5 angles of a pentagon. Do you remember? We need to use this formula. There are 5 sides. 5 minus 2 times 180 is equal to 540. The sum of the angles of a pentagon equals 540. So we're going to use the ratio that's given, 11 to 7 to 5 to 4 to 3, to write this equation, 11x plus 7x plus 5x plus 4x plus 3x equals the sum, 540. Solve the equation. X ends up equaling 18. Is that the answer? No. It asks us to find the measure of the angle. But plug that in, 11 times 18, 7 times 18, etc., and you get these 5 angles. Oops. That gave it away. I do want you to try these on your own. Show your work. You just saw the answers if you're paying attention. If not, go, and I'll show you the answers here in just a second. Process should be similar as what you just saw in example 3. How did you do? These are the answers. Surprise. Okay, on the back of the page, we're going to talk about a proportion. A proportion is a statement that two ratios are equal. You'll usually see it in these two forms, either like A over B equals C over D, A to B equals C to D, or you'll see it written out as A to B equals C to D in this form. But they say the same thing. This is an equation. Now, we can use the properties of an equation. But we can also see it as an extended proportion. This is a term that you'll see. An extended proportion is where you can actually set more than one ratio equal to each other. Now, here are a couple of terms that are really important for us to be able to talk about with this. The first and the last terms of a proportion are called the extremes. The middle are called the means. So in this ratio over here, A and D, the first and the last, or the first and the fourth, if you will, are the two extremes of the ratio. The C and the D are the two means of the proportion, I should have said earlier. So A and D are the extremes, C and B are the means of the proportion. And the same would be true if it was written in the other form. A and D are the extremes, B and C are the means. It's easy when it's written in this form that B and C are the two in the middle. Okay, I'm going to do a little bit of experiment here. If you're paying attention, write the word banana under the statement here for proportion, between proportion, extended proportion. Don't tell other people that may be skipping this portion of the video. Okay, now there are properties of proportions. These are really properties of equations, but because we're talking about two ratios being equal, they're proportions. The first one is this. The product of the means is equal to the product of the extremes. In algebra, you call this cross multiplication. So if you have 2 over 3 equals 4 over 6, you can write it as 2 times 6 equals 3 over 4. This should sound familiar, and that can happen anytime you have a proportion. It's important that it's a proportion, that there's an equal sign in between before you do that. Some students get confused between that and multiplication sometimes. You can interchange the means. If you have 2 over 3 equals 4 over 6, well, 2 over 4 equals 3 over 6. The things in the middle can exchange places. Okay, property number 3 here. You can take the reciprocal of both ratios. So 2 over 3 equals 4 over 6. We can flip that and have 3 over 2 equals 6 over 4. Look what happens here. The means just became the extremes, and the extremes just became the means in this case. So, and then you can apply the property above and switch those around. So we can exchange the means and the extremes, really. Property 4 here, we have an equation, really. Proportion is an equation. So whatever you do to one side, you can do to the other. So this says you can add 1 to both sides. You can add 2 to both sides, 3 to both sides, 1,000,000 to both sides. It really doesn't matter. But there's a reason why it's important to think in terms of ones, and we'll get to that as time goes on. But 2 over 3 plus 3 over 3 is equal to 4 over 6 plus 6 over 6, and that's what they're showing over here. And of course, what does that equal? 5 over 3 equals 10 over 6. And you should recognize those as equivalent ratios. And this is a really interesting property. In an extended proportion, if you have 2 over 3 equals 4 over 6 equals 6 over 9. Then you can write that as a sum. So 2 plus 4 plus 6 equal over 3 plus 6 plus 9 equals 2/3 equals 4 6 equals 6 9s. And there will be times when that's going to come in handy. So put that in the back pocket. Okay, the main thing we do with proportions is we use them to solve for variables. So if we have this proportion here, x over 5 equals 3 over 2, then you can cross multiply. So 2 over x, oops, I'm doing the wrong thing here. I'm sorry. These ask you to complete these guys here. So if x over 5 equals 3 over 2, then what does 2x equal? I'll let you finish this, but what's going on here is that's using the cross multiplication or the property of the means and extremes there. On number 2, I hope you can recognize that what's going on is it has 1 being added there to the first one, so you want to add 1 to the second one. On number 3, hopefully you'll see 8 over 9 gets flipped, y over 8. So what does it equal to? Fill in the blank. On number 4, 5, and 6, give those a shot and see how they go. Okay, are these what you got? I hope so. We'll talk about whichever ones didn't make sense in class. Now, the next piece of this, which proportions are equivalent to a over 7 is equal to 4 over 21? It's asking which of these three things is applying these properties that are above. See if you can figure out which ones are the ones. Did you figure out that A, B, and C are equivalent, but D is not? I hope so. Okay, finally, I thought we were here earlier. To find the value of x, this is one of the main ways that proportions are used. If you have 6 over x equals 3 over 5, we can use these properties that we have just been talking about. The primary one you're going to be using is the cross multiplication one, or the means and extremes property. So if you have 6 over x equals 3 over 5, cross multiply. 30, 6 times 5, equals 3 times x. 30 equals 3x, so x equals 10. That's simple enough, and a lot of these are that simple. I'm going to do 13 with you here now. We can cross multiply, so 2 times x plus 2 equals 12 times 1. Then the equation solves as such. All right, give these last a shot. At least do 2 from the top and 2 from the bottom at least, and show me your work. And then you'll be done with this exercise. Answers coming up. All right, hope you did well. Hope you have a good rest of your day and get some rest, because you know about tomorrow. Bye-bye.